Hello. And we begin. All right. So, good afternoon to everybody who is here. 245. How was English? The normal. All right. Cool. Okay, guys. So tomorrow is the math exam. So today is our last day here. All right. So we'll give it a good shot. Right now, last week and the week before, we were working the past papers. And the majority of you guys were able to get through the first 6, 7, 8 questions, and the last 3 questions, which were vectors, matrices, circle geometry, trigonometry, and the question 9, which would have been like relations and functions, and well, not that one, but so we covered the completing the square and the what was it? I think yesterday. Simultaneous equations, thank you, where one is linear, one is non-linear. We covered that yesterday, right? In the more recent years, they actually haven't brought those things, to be honest. Which one is that?
The linear, how do you work it out?
Yeah, I have it.
For the solution, for the thing the other we're doing on island.
Well, all of it written down, so I have everything from yesterday. Yeah. Anyway, when you go home, message me, or before you leave, message me, and I will just email it. That's no problem, right? All right, guys. So today, what I want to do is I want to go through those variance questions, right? Now, of course, we do not have infinite time, and things take time to explain, and then they take time to work out. So the objective is this: we're gonna hit bearings first, followed by circle geometry, then we're going at that point in time, I'll look at about 6, a little after 6, we'll take a short break there, and then we will hit after the little break, we will do matrices and then vectors, right? So of course it won't be from scratch per se, because we don't have time to do all that. It'll just be kind of on the fly. So the plan is basically to do one of the questions as an example, and then kind of walk you through the second one, and then you will try 2 questions, right? So that was the plan if we had started at 4 o'clock, right? But of course I knew that wasn't going to happen, so we'll just kind of fix the suit as the case may be. All right. So if anybody in your live, thanks for joining, right? Hope this helps, right? If you have any questions you could ask, I'll try to answer as I go along. Hold on, what's going on here?
So this is from May 2020.
Yeah, if you look at the front of the printout that I gave you, you will see all the years on the front there. All right? All right, cool. So let's take a look and see what's going on, right? So yeah, this is the May 2018 question. Let me just confirm that. Yeah, May 2018. Okay, so before we get into that, let's just recap. So I will have to do at least a very basic description of what a bearing is. Yeah. I gave it to, I know I was one short somewhere. Thanks. Which one is that? The same one? All right, cool. Thank you very much. All right, cool. What, sorry? A blue pen. Blue. Catch? All right, cool. All right, so bearings. All right, so basically what happens is we have 2 points. Let's call it point A and point B, just for the sake of simplicity. And of course, we have a distance between point A and point B. But what a bearing is, wow, we're right into the real off boy. Right, cool. So that's a north line there, and this is the north line at B. So what a bearing is the, put it in blue, right? Is the angle going clockwise measured between the north line at the start point and the line joining the 2 points together. Right, so this bearing, let's just estimate that one at 50 degrees. Right, so what this is here, this is actually the bearing of B from A. Bearing of B from A. Right, so the bearing is the angle between the north line at the start point and the line connecting the 2 points, point A and point B, of B from A. Right, and usually what they ask you guys to do is to find the bearing of A from B. So, right, so we are required.
So I could send the link to
Yeah, no problem. right? So the bearing of B from, sorry, the bearing of A from B. Right, now the bearing of A from B. So what I'm gonna, let me just reproduce this diagram because I don't wanna clutter it up too much, right? Oh crap! Right, copy. Right. Cool. So let's paste that. Paste that there. All right. Coming for the maths, fella. Cramming for the maths. All right. Cool. Okay. So the bearing of A from B. Actually, let's put that below. I feel like I'm gonna run out of space on the side there. So let's just play smart, shall we? Cool. A little more space. All right. So the bearing of A from B, once again, what is the bearing? The bearing is the angle between the north line at the start point and the line connecting the 2 points, going in a clockwise direction. Sorry, I forgot to say that. That's a very important aspect of bearings. You have to go clockwise from the north line until you hit the line connecting the 2 points, right? So this is the angle that we want. So how do we get it? All right, so one thing that we could do, sorry, I don't know why this erase feature not working, so I'm just gonna use the erase at the back. Right, so to find that angle there, what we do is we actually extend the line that is joining the 2 points. We extend that line a little bit. Now what you're supposed to be able to see from this is that we have F angles, right? So remember, F angles are formed, right? If you have two parallel lines and you draw a line through them, if you look, you can see an F. I'm going to highlight it in yellow. All right, cool. So we see an F being formed there. Agreed?
Yeah.
All right. So what's going to happen is that the angles, what you're calling the corners of the F, are going to be equal. So let's call that A. We'll call that A, and then the angles on top here as well, right, will correspond. So they're called F angles or corresponding angles, right? So basically, what you're seeing here is an F that's kind of lying down on its side. And what it implies is that this angle here, just this piece right here, is equal to that angle there. So that's 50 degrees, right? Now, remember, what is a bearing? The bearing is the angle between the north line and the start point and the line connecting both points.
Yeah.
So what we've done is we've broken up that big angle, right, into two pieces. We have the yellow piece on top, which is the 50 degrees, and then we have this blue piece below here. Now that blue piece actually lies on what kind of line? A straight line joining the 2 points. And what is the angle on a straight line? 180 degrees. So all we have to do to find the total bearing therefore is what? Add the 50. Remember, what we want is the angle from here going this way. Right? So the top portion is the yellow piece and the bottom portion is the blue piece. Right? So yellow plus blue, well, it's green, but 50 plus 180 will give us the whole angle. So the bearing of A from B will be that 50 degrees plus the 180 degrees, which is 230 degrees. Right, the bearing of B from it. So this is point B here, right?
Oh, it's upside.
Right, the bearing of B from A is the 50 degree one. That's this one here.
So since it's upside down.
Well, I don't know about the upside down, but it's on its side. Okay, right, it's lying down. So yeah, so you have to know how to spot the F angle, right? So F angles could also be, if we have a line going so, right? So, I mean, you have different ways to see it, right? So you have, once again, your two parallel lines going like this, and you have your line crossing like that. So this angle here is equal to that angle there. All right. Okay. All right.
What about the angles in between?
What this angle here?
Yeah.
Right, so that angle there is actually, these two angles here are what you call supplementary.
Yeah.
They add up to 180.
Well, what does it mean? Because I keep thinking it's corresponding with this.
No, they're not corresponding. These are corresponding angles here.
Yeah.
Right, so corresponding angles, also known as F angles. Okay, right, so that's the first, right, the first example. Right, now, let's say you had a second instance, right? So this is the first example. second instance, let's call it example 2. So let's say you had, let's say, point C here and point D here. Sorry, that looks like a B, my bad. Point D. And you had a line joining C and D. Right, let's see. And of course, you have your north lines. Right, north lines are important to being able to solve vectors. They help a lot. And let's say in this particular instance, the bearing we are given is D from C. All right, so we have the bearing of, so D from C. So that would be that. So let's say is equal to 250 degrees. And we are required to find the bearing of C from D. So what they want us to find, so once again, the bearing of one point from the next is the angle between the north line and the starting point. So if you're coming from D, right, C from D, D is the starting point, going clockwise, right, the angle between the north line and the line joining the 2 points. So this is the angle they want here, right? And we know that this is 250 degrees. Yeah. I made it up as the example. All right, so let's copy and paste this diagram just below. All right, so let's copy that. Let's paste it right here. Okay, so we have to find, yeah.
So how come?
Uh-huh.
So we require to find the angle by D.
Yeah, you have to find the angle by D here. All right. So what we use up here just now, we use the fact that the north lines were parallel and made use of F angles.
Yeah.
Right. And if we also made use of the fact that the angle on a straight line is 180 degrees. So the trick behind getting through with bearings questions is extending lines to be able to cut bigger angles into smaller angles and using the relationships that become apparent. Right. So, oops, sorry. Right. So if we extend this line again, we would cut that 250 degree angle into two pieces, right? Of course, the bottom piece here is on a straight line, so that's 180. And the remaining piece on top would be the 250 minus the 180, which would actually give us 70 degrees. And if you notice, this is the same diagram from above in terms of the generic shape. So we have the F angles once again. So this angle down here is just going to be 70 degrees. Yeah? All right, cool. So 70, 70. All right. So that's the basic gist behind north angles. So remember, the major things you have to be mindful of with north angles, major things you have to be mindful of with bearings are the north lines. All north lines are parallel, which facilitates therefore using F or Z angles. Yeah, yeah, of course, right? No problem. I should have washed my hands. I was holding the door. Anybody else want to print out these notes? Or you're all okay? Okay, so one printer for.
I figured I used a printer.
All right, so you want the printer or not? Or you have it?
I have.
You have it? Okay.
Could I have one?
All right. Okay. So Karen, you okay? Craig, you okay?
Oui, c'est sûr. Again, what was the difference?
One, in this particular case, it started off that this was your initial starting point. And so basically, if you consider like your north, south, east, west stuff, right? We initially had something from west to east, the bearing of a point east from a point west, right? In this second example, we reversed it, right? So in this second example, correct, we started off with a point in the east, going to a point in the west, and now you wanted to reverse the bearing. All right, okay. Let me just print this real quick. Let's hope the printer doesn't die. No, it have ink, and I have more ink on top of that as well.
Oh, but it's just the printer.
Yeah, well, I've had it since 2014, eh?
Oh, well.
Yeah, 2014, 2015, 2016, 2017, 2018. That's 5 years. 5 years.
Well, that's good for printer.
And that's 5 exam seasons, eh?
Oh. That printer plenty right there.
Yeah. And five CXC exam seasons, and 5 mock seasons, and 5 Christmas exams. So that's technically 15 exams, plus July, August classes in between that.
Well, yeah.
Yeah, so it was about time. Okay, guys, so taking what we know here, what we're going to do is we're going to go back to our question across here, which is the May 2018 question, right? So we're just going to give a second. Okay, can you reach back? Okay, you know, I swear I put the notes up. Okay, now just went. Yeah, bring it now. Yeah, cool. Let me just check.
Supplies are very good.
Yeah, as always said, don't worry about it. Hi to all 14 of y'all. Thanks for joining us. I hope you guys finding everything helpful. Right, if you have any questions you could ask, hopefully I could help you. We're just waiting on something to print here, and then we're gonna do this question. So in the meantime, you can read the question, you can take a screenshot, you could draw it out real quick. If you have the paper, well, you could use it. Now, it was you, Antonio, and Jordan, and I given Jordan an extra one to carry for Laura's.
Oh, she's not feeling well.
Yeah, you're not feeling well.
Tell her, tell her. Tell her, she was fine. Oh gosh, John. It's gonna be vexed.
All right, so let's go. Sorry? Oh, that's the extra one for Laura. Yeah.
Oh, you didn't want to know?
No, I said I was giving him two because she's not here. All right, so first thing to do is to read the question. So let's go. So number 9. The diagram below, not drawn to scale, shows the relative positions of 3 reservoirs. Whoops, what did I do? Something I'm not supposed to do. I don't understand why pressing undo skips it back. Anyhow, so I have to not press undo. All right, B, F, and G. So you have B here, you have F here, you have G here. Cool. All on ground level, so they're on the same horizontal plane. You okay, Antonio? You're cold or no? All right. The distance BF is 32. We can see that here. FG is 55. We can see that here. BFG, BF. Anybody saw that movie? BFG. It was all right. Right. It's 103. That's that angle there. And F is on a bearing. So F is on a bearing of 42 degrees from B. So F from B is 42 degrees. Okay.
Oh, see.
I know. Okay, so the first thing they're asking for is the bearing of B from F. So all right, talk to me. So how do we do that?
It's very simple. So you add 180 plus 42.
That's Stefan, what's going on?
Right here, so nice.
So you add 180 to 42, and you get 220. Right. So the shortcut is once you're trying to find the bearing of something west from east, you add 180. So right. So if you're trying to reverse a bearing like this. From this point here, just add 180. So long story short, but the other way around is minus 180.
Okay.
So if you go, yeah.
Anytime you're trying to find a bearing from west to east, just add 180.
From west from east, right? So what? Hold on. They want the bearing of B from F, right? So if you draw your north line, right? So this is west here, this is east here, right? They want the bearing of B from F. So relatively speaking, B is west of F, not so?
Yeah.
So if you're trying to find the bearing of something that is to the west of another point, right? So, and you have the original bearing here, the 42 degrees, you just add 180 to that. But, of course, now let's just see how many marks for that, right? Okay, well, there's 1 mark, so so really and truly, perhaps we're doing bearings, I would guess. Yeah, we're doing bearings.
From B.
F from B is just 42. You have it already. But B from F, so check it. The first thing I would do is I would draw a north line at F. Let me get a thicker point, sorry. Right, so we draw a north line at F. And we extend this line a little bit. Right, so remember, what do we want? We want this whole angle here. Right, now we have so remember this whole piece here would be what? That would be 180 degrees. And this piece on top here would be equal to 42 because of F angles. Right? Yeah, Stefan is bearings. Then we're gonna do some circle geometry after. Yeah, sorry, question?
No, I just realized something. But also, so the bearing of from bearing of F from F to B.
From F, okay, the bearing of B from F, yeah.
B from F, that's the 42.
No, the 42 starts at B, right, isn't it?
Yeah.
So if the 42 starts at B, that's the bearing of F from B.
Oh, so that would be going from
B to F.
That would be west to east.
That's west to east, that's correct.
Okay.
Right? Right, so like I was saying, this angle on top of here is 42 degrees as well. Okay, maybe I should go back to that thinner point. Right, so that's 42 degrees. And that's because it's equal to this angle because of F angles. And why F angles? Is because all north lines are parallel. So you could tell, okay, well, nice, that's good, Stefan. A lot of people not strong in it at all, so I'm glad you get some little practice, right? So therefore, if we have determined that the components of this bearing are 42 and 180, what do we have to do to find the whole bearing? Let's add them together, right? So the bearing of B from F would be 42 degrees, which you could label as F angles if they want a reason. F angles or corresponding angles plus 180 degrees, and I could say angle on a straight line. Alright, so that's 222 degrees. Alright, so if you want, you can put your answer down here, right? So bearing of B from F is 222 degrees.
Oh, so we didn't have to find the inside angle, right?
The inside angle, when it, I'm not sure what inside angle. Practice makes perfect, I agree, Stefan. Maybe she butt dialed you. Alright, anybody have any questions on that first part there? Or are we okay with it?
That'll be good.
We're good? Okay, let's check out the next part one time. Alright, let's just erase that quickly. Alright, calculate the distance BG.
Oh, wait, what was I asking? Right.
You were talking about something about an inside angle.
Yeah,
I'm not sure what inside angle you were talking about.
It's the angle that you're pointing to, from the 42 to the F.
This angle here?
Or the angle on the
And
other
the
side.
inside.
Oh, you mean the inside?
So you don't have to find that angle. Right?
It's not entirely necessary, but I mean,
That's the angle.
if you were able to find it, what you could do is take it from 360.
Yeah.
Because it's the remainder of the full circle, and the bearing is the other side of it.
Well, we need to
Right.
minus 180 from 42.
Correct.
I mean, 360.
Yeah. So that could be 360 minus 180 minus 42.
Oh, no, well, I always
Right.
thought it was the inside.
So what's that for?
Just so if he wanted to find the middle angle.
IDK, what going on? You don't know what's going on? Alright, sorry, if you have a question, you can ask. Yeah.
Minus 1.
This piece here.
Or that?
Yeah, you get 42. Sorry, you minus 42 from 180, you get as 138.
So they could have asked for it.
Well, yeah, they could ask for it.
Well, I always thought that was the answer itself.
No, that's not the answer. That's never the answer. Right? Remember, because that would be going anti-clockwise. And with bearings, we have to go clockwise. Alright? Alright, so let's take off some of that stuff, alright? Take off all the annotations. Alright, so the question asks for the distance BG, which is that distance there. Now, this is what kind of shape is this? It's a triangle. Is it a right angle triangle? No, it's not. So because it's not a right angle triangle, we can't use Pythagoras Theorem because we have two of the sides, not so?
Yeah.
If it was a right angle triangle, we could have said, okay, well, the square of the hypotenuse is the sum of the square of the other two sides. But we can't do that because it's not a right angle triangle.
That's using cosine.
Right. So if it's not a right angle triangle, it comes down to either sine rule or cosine rule. Right? Now you could actually, in any triangle, you could drop a perpendicular and make it into two right angle triangles. But you would need sufficient information from there to be able to solve that question, right? Now, what Jordan said was correct. We have a setup that we could use in order to find that missing side. But if we have a triangle and we have two known sides and the angle between, and we're looking for the side opposite the angle, that's simply given by cosine rule. C squared is equal to a squared plus b squared minus 2ab cosine c. Right, so that's cosine rule. This is actually a modification of Pythagoras' theorem, by the way. But we will not get into that right now. Right, because as you can see, the first three items are basically Pythagoras' theorem. But that derivation, we're not going to go into that right now. Alright, so all we have to do is label our side. So let's call this side A, we could call this side B, and this is angle C. Alright, so what would it look like? It would be 32 squared plus 55 squared minus 2 by 32.
For BG, right?
Yeah, this is for BG. By cosine 103. Alright. So if someone could plug that up, I'd be grateful because came for some maths. Hi Josh, how you doing? Afternoon. How was English? Yeah, anybody could give me a figure for that because I don't have a calculator.
Yes, no.
I'm a brain arm. Sorry, what? Brianna have me? Alright, well I hope so.
Oh no. Wait, I get to square it.
You forget it? No, I don't want anything square rooted yet.
Oh.
I actually want this is exactly equal to
4,840.83.
the answer, Stephanie, yes you do. You get those formulas in formula sheet. Sorry?
4,840.832.
So you're saying 4,840
You got that correct? Yeah,
point what?
83.
0.83, right. So two decimal places. Now that's C squared. So therefore, how do we find C? How do you undo a square?
You find the square.
You have to find the square root, right? So you have
69.
4840.83. How much?
69.
0.58. Now let's see what the answer requires. The 1 decimal place, right? So if it's 69.58, that would be 69.6. All right. So you can say using cosine rule.
So it's 4,840.
If 4840.85 or something. 82, sorry, right? So we got approximately 69.6. Now don't forget your units, it's kilometers.
Yeah.
Oh, but that answer would be squared still.
No.
Before 4840 is the square. So now to undo the square, you have to find the square root. Live sticking? Is it sticking, you sure?
I'll tell you.
No, I don't think. Yeah, let me know. No, it is okay, there was a report. Hey Liam, how you doing? 69.6, correct. Alright, cool. Okay, no, I think we're okay.
No, it doesn't know.
Alright, cool. Yeah, sorry. Yeah. Have a seat anyway, Liam. We're doing some bearings first.
69.5, yes.
Yeah, but to round it out, yeah, 1 decimal place, so 69.6. Alright, cool. Alright, let's go back up and so we can see that working. So this was the working for that part of the question. Of course.
Just for you know.
Yeah. So what we're gonna do is just don't worry with them, Liam. How was English, Liam? It was good?
I
Alright.
just felt bad, like
Uh-huh.
I finished really hard, like
Everybody finished.
I finished up all one.
Oh, Liam, what you write to that paper?
I wrote, I started writing like 550 words. I cut out some stuff. I white out some
You
stuff.
can't write anything.
You can white out in POA.
You cannot use whiteout in any exam. You know I'm supposed to have it in the exam room.
Well, I wrote it on, you know, the other pieces of paper they give you.
Yeah.
She told me just cross it out and I wrote it over there. So I wrote.
You wrote
Yeah,
the question number?
Yeah.
Did you do all 4 questions?
Yeah.
Okay.
Liam.
It's up that one with the
Argumentative.
that one was funny. That one was funny.
What you wrote?
Alright, Stefan.
Yeah.
Okay, Viresh, thanks very much.
I just thought it was real tricky.
Alright, cool. So we have just found that. So calculate to the nearest degree the bearing of G from B. The bearing of G from B.
Question 9 was on that. Well,
We're on the first one, yeah. Yeah, we didn't start too long. Right? All that extra stuff is multiple choice for you to go home with and practice tonight. Right? Okay, so I'll put it back just now, right? So what do they want? They want the bearing of B from G. Now let me just erase.
So G from
They want G from B?
Yeah.
Oh, sorry.
G from B.
Yeah, sorry.
This way.
So they want G from B. So they want us to start from the north line at B and go clockwise until we hit the line joining B and G.
Okay.
So this is the north line here at B, and they want us to go clockwise until we hit G. Now, do we have any portion of that angle?
Yes.
We have a, right, correct, 42. So really and truly, all we have to do is what? Find
180 minus 42.
180. Why 180?
Oh, sorry.
Well, 180 will give us this whole piece here. But this piece on the outside here would be irrelevant to what we have to find. All right?
F angles.
F angles. Well, we could draw a north line, right? If we draw a north line and extend, yes, you could get your F angles here and here. But then you have to find the angle on the outside here. All right? Now, all we really have to find, like I said, is the angle on the inside of the triangle and then add it to 42, not so?
Yeah.
Right. Now, remember, we just found this side as 69.6 kilometers.
How come
So that's 69.6.
Well, we just that was you just walked in after you finished that part, but I'll put it back up on the board just now, right? Sorry, Brian, your question?
How come you have to add the 42?
Remember, the bearing of G from B is the angle starting from the north line at B and going clockwise until you hit the line joining the 2 points. So it's this whole angle here. Well, we have this piece on the outside here, which is 42. So all we have to do really and truly is get the piece inside of here and add it to the 42. Yes? Well, to do cosine rule, we could, because look, we have all 3 sides. So we could do a transposition of cosine rule, or What's the other rule apart from cosine rule?
Sine.
Sine rule. All right. So, still sticking, boy? All right, guys. Look, I'm just doing some movements here. If it's still sticking, let me know. Sine rule.
No, like you talk about you talk about trends.
Oh no, I did. We can't use that one right now. All right. Okay, so we'll be using sine rule. All right. Yeah. I did some movements here on the screen, but it's not popping up in your live. All right, guys. Just give it a minute. If it's still not thinking, I will. Okay. I see you in a shift. Hold on. Wait.
What's the name of the thing right now?
A different approach to Tuition Limited.
I'll subscribe to it.
All right, cool. All right, guys. Here what we're gonna do. Since it's sticking in between. You had to write fast too little time. I had to write fast. Okay, sorry about that, Kimmy.
Oh, it just moved.
It just moved. All right. All right. So sine rule is equal to a over sine a equal to b over sine b. Right? Now my thing is, if you are looking for an angle, which is what we are looking for here, we're actually looking for this angle down in the corner. What you can do is simply invert the sine rule. It makes it a bit easier in my opinion, right? Now you don't have to, right? So we could get that sine. Now we're looking for sine, okay, sorry, we're looking for sine b actually. All right, so we're looking for sine b. So sine b over b in this case. Now look, the only pair that we have, the only corresponding pair of angle and side is f and the side opposite f. So we could say sine b over b is equal to sine f over f.
So Chris,
Uh-huh.
when you're doing sine rule, right?
Yeah?
You would be able to interchange b over sine b and sine
Yeah,
over b.
because all you're doing is really just you're flipping both sides, so you're not really changing the equality.
So you just work according to what they are for.
Correct, yeah.
So technically that's sine C as well.
Yes, that's correct. Right, so to find sine b, what we'll have to do therefore is simply multiply by the denominator of b on both sides of the equation. Alright, so I hope I'm not moving too fast, Kimmy. Alright, so you can write down your stuff. No, I can't use Pythagoras.
No, to find out 69.6.
No, that was cosine rule. I can't use Pythagoras because it's not a right angle triangle. Right?
So sine 103 69.
Correct. So we have sine 103 degrees
By 40.
over 69.6 multiplied by 55. Right? Remember, this is the side opposite to the angle we're trying to find. Alright? Alright, that's B. This is F down here. Alright, so if somebody wants to just plug that up in their calculator, so you can do sine 103 divided by 69.6 and then multiply by 55. Yeah, you will get a decimal, right? It'll be 0 point something something because that is what sine B is equal to.
I went 0.769.
You get us.
0.129.
Make sure first of all, make sure your calculator is in degrees.
Yeah.
Alright?
Chris, when you're doing the sine, the inverse of sine, do you use like the full number or do you short?
I would say when you're working on your calculator, leave the whole number. But if you have to write it out on your paper, you can shorten it. That's fine. And you can put like 3 dots after you shorten it to show that there's some more stuff after. Alright? Yeah, anybody could confirm what that is?
0.76. Yeah, that's 0.76.
0.7699?
Yeah.
76. Dot, dot, dot. Right. So therefore, to find out.
It was 0.769.
Alright.
0.7.
So to find angle B now, we have to find the sine inverse of 0.769. And the sine inverse of 0.769 is approximately equal to?
Sine inverse. And not square root. Sine inverse of 0.769.
Yeah, 0.769.
50.26.
50.26, so about 50.3 degrees.
Yeah.
Alright. Now, we're not done because remember, Right, that's just this piece on the inside here. What did they ask for? The bearing of G from B. And that's this whole angle here.
You have 50.26.
Yeah, we rounded off as 50.3. Alright, so therefore, the bearing of G from B would be equal to
Chris, I didn't.
uh-huh.
I said I didn't the other way, so I didn't do it. I did the 55.
That's fine.
Sine B equals to 69.6 sine.
You could do that. That's fine. No problem. Right. So you have to be careful how you're plugging it into your calculator, right? All right. Hold on. Call out again what you said you had for me. So you said you started off with 55 over sine B, and you and sorry, not multiply. That's equal to what over what? 69.6 over sine 103. Okay. So the first thing we could do here is what they call cross multiplying. So you multiply each side by both denominators. Hi Emir, how you doing?
I divided first and then multiply.
You divided first. When you say you divided first, what?
69.9 and the sine 103, and then I multiplied by 55. Is that wrong?
All right. So if we divided by that, but then how did you move your sine B? Hold on. Watch my board. So if we cross multiply, right? You're multiplying by each numerator by the opposite denominator. Alright, 69.6 by sine B. And now to find for sine B, we have to move 69.6. How is 69.6 attached to sine B? What operation? And to move something attached by a multiplication, what do we do? The opposite, which is division. So this is what your item should look like. Did it look like that? And if you notice, that's the same thing, that's the equivalent to what we have across on the right hand side.
Yeah.
Alright?
Yeah.
Oh. Alright.
This is the 3-4
The tree fall, what tree? Which tree?
The one like the cafeteria.
Or the cafeteria fall? On what? On the galvanized or on the field? Oh, wow.
Like half,
Yeah.
like the left. So if you like looking
Uh-huh.
at it from the form one block, the
Yeah.
left side fell on top, close to the new form. Like
Yeah,
the block
yeah, yeah.
built and half fell on the roof.
Wow, okay. Oh,
It just fell.
I guess it's the dust and the heat. Heat in the place. Alright.
Hey, Chris.
Uh-huh. Yeah.
That 42 plus 80 equals 2 times 2.
Oh, that was the bearing of B from F. That was the first question, right? What we did there is we kind of extended the line, and we said, okay, look, this whole angle here is 180 degrees, right? But remember, we want the angle from the north line going that way, and that angle here was 42 degrees because of F angles.
Okay, so you just...
Yeah, you just added both of them together. Yeah. So look. What you doing? You draw a north line here, and you extend this line. Sorry. You extend this line. Why? What happened? Thing not right then? Be yourself. Right. So what we're saying is, if you notice, this piece here is like a sideways F.
Okay.
Right? Like if you have two parallel lines and a line crossing them, these angles are equal to each other, and that's this angle here, this angle here.
Oh, so you want us cutting and F is 42 and
Yeah. And then the remainder of this going all the way here is 180. So that's why we have 180 plus 42.
just to see that.
Yeah. Uh-huh.
When I divided this, I got 0.766.
Yeah, that's fine. That's fine. Right. So you get 0.766 something.
Yeah.
All right, cool. So that's equal to sine B.
Yeah.
So now to find B, you have to find the sine inverse of 0.76, whatever it is.
You explain. Oh,
Yeah.
49.
49 point? Yeah, so approximately 50, right? All right, cool. Okay, so I'm okay with the 50 degrees. And don't forget, we're not done. After you find that 50, you have to add it to the 42. Because remember, what we're looking for? We're looking for the bearing of G from B.
Yeah. Okay.
All right, cool. All right. Let me just scroll down. So I hope everybody in your life had time to copy down. I know somebody said it was too fast.
Okay, yes.
So I hope I'm not going too slow now, right? I'm scrolling down a little bit.
BG.
Yeah, for BG we use cosine rule. Yeah, hold on. Let me just get a diagram, right? We had we had this length here, right? So this was B. The question. Let me just see the question that would help.
degree.
Right.
So if it was 92.26, it would just be 92.
All right. William. So we had the diagram we had that particular setup, right? And because of that, we were able to use cosine rule in this format here.
Yeah.
All right. So it was just straight. You plug in the figures. Rahul surgery. Hey Rahul, where you going, boy? Stun attack. Wait, somebody from FB was messaging me. Thanks for joining. All right, cool. All right. So the bearing of G from B we said was equal to, what was it? It was 42 degrees plus the what? 50, which gave us approximately 92 degrees. To two significant figures. Two significant figures. You can use 92.3. Oops, it just blanked out and came back. Okay.
Oh, that was the question we just answered.
Yeah. Right. I didn't put the work in. I didn't write over the work in because I did it up there already, right? So
the 92.3 just being rounded off to
it said nearest degree.
Okay.
So 92.3 when you round it off to the nearest degree is 92. Yes. Okay. All right. So that was the May 2018 question. That was last year's question. So it was relatively straightforward compared to some of the other things we've seen in the past. So what we're going to do now is take a look at one or two questions from the past. All right. So we're going to turn back. Right. We'll turn forward in the booklet. All right. Those only live. So it will stick in. All right. Cool. Let me see if I can help that out. If it's sticking within the next 5 minutes again, guys, I'll disconnect the live and just reconnect it because that was happening yesterday too, and it was frustrating everybody. So sorry about that. I have no control over the internet though, except to reset the router. All right, but yeah, I tried to monitor the chat here so I could see if when people complain about the sticking. All right. Okay. Yeah, and sometimes another that's sticking, and sometimes I might leave it on one. Yeah.
Just give me 2 seconds.
You could take it from me.
Yeah.
Because you could put these, do we have to put 0.92? 0.92?
Actually, you make a good point because bearing should be expressed. Right? So it should be 0.92 degrees. Yeah, because bearing should be 3 digits. You're correct. Yeah. Yeah, so you see sometimes things slip my mind too, huh?
Well, I thought, because I had absolutely just the other day, I think
Yeah.
I got it wrong or something.
Because they didn't put 3 digits.
Right.
It shouldn't be wrong. You should just if it's like a tick for it, if it's a mark, you should just press a half mark. I wouldn't give you a wrong.
She got a whole mark.
What year is this question? The question we do now is the May 2017 question. Right, we just finished May 2018, we do May 2017.
Chris,
So
this topic
yeah.
usually comes interchangeably with bearing, not bearing, circle geometry.
No, not interchangeable. It comes attached to circle geometry. So this is the part A and circle geometry is the part B usually. Right? The other thing that could come in place of this is like angles of elevation and depression.
Oh, yeah.
But the 3D, they haven't brought a 3D question in a while. Yeah. Alright, let's take a read of the question. Right? So, you all ready?
Yeah.
Alright. So, a ship leaves port A and sails 52 kilometers on a bearing of 044. So, you're right, Brian. Look, even in the question, they put 3 digits, right? 044 to port B. The ship then changes course to sail to port C 72 kilometers away on a bearing of 105. Alright. Let me actually try and do this other than just watch. Yeah, that's a good idea, Virish. Alright, so let's just track this journey because the first thing they want us to do is on the diagram below, not drawn to scale, label the known distances traveled and the known angles. So, and they give you 2 marks, eh? So all you have to do is put it in. So let me see you guys try this one. Let's try that one. So put in the known. You tried it already? Everybody? I stick in then. Alright. Alright, so let's do the distances first, right? So from port A to port B, what's the distance? 52 kilometers, so 52 kilometers. Alright, and then the distance from port B to port C is? 72 kilometers. Didn't we have those distances just now? I feel like we did. What we had just now was 103 or something.
5 and 32.
Good. I just remember the 2. Alright. And they said it was on, so the bear, and then, okay, let's go on to the bearings now. So we have port A to port B is on a bearing of 44 degrees. Let me zoom in a little bit so I don't have to write so small. So 44 degrees, and we put the angle. Alright, if you want to put your 0 inside it, that's cool. I just don't have too much space, so I'm trying to conserve one space, right? Alright, so 40. What's that? Yeah, you could extend the north line. That's actually a good idea. Alright, north. Okay. So that's the first bearing, and the second bearing of 105, that's the bearing of C from B. Alright, so that is 105 degrees.
Chris, how come I can't be underneath?
What can be underneath?
That would be. How come I can't be like.
We're talking about an angle or a length?
Yeah, like that, like.
Oh, this piece here?
Yeah.
Alright, so that has to do with, once again, the definition of a bearing. Question?
No.
Okay. A bearing is the angle between, watch on the board, right? The north line at the start point. The angle between that line
Yes,
and the line connecting the 2 points.
Alright.
Right? Alright, so that's the first thing. So,
Wait,
yeah.
so it can't go below.
No, yeah. Bearing is between the north line.
Unless they specify and ask you for the angle, like inside.
Alright, that's probably actually the very next question. Determine the measure of angle ABC. Right? So check it. The angle ABC, sorry? No, ABC starts at A, goes to B, and then ends up at C. So that, right? So that's the same thing.
You did the same thing that you showed us before.
Right, so let's take a look and examine what we could and could not do, right? So they want the angle ABC. That's this angle here. Now, do we have any angles inside of that triangle to assist us in this? No, we don't.
So I use cosine rule.
Cosine rule. Now, we could use cosine rule to find angles if we have all three sides. Do we have all three sides? Ah, we don't know this side across here. Now, this side, by the way, this is small b.
Need the angle in between and need to measure on the side.
Now we need the angle here, that's correct.
Right.
And we have those two measurements.
Right.
But the thing is, we don't have sufficient information inside the triangle to facilitate finding that angle. But we can create it. Alright? Now Pythagoras Theorem works when you have a right angle triangle. The thing is, we have no angles inside and no other information. If they told us, for example, that C was due east of A. Now from our cardinal points, if this is north and this is east, what's the angle between?
90.
That's 90, right? Miss you, sir, is it Isabella? Hey, Isabella, how you doing? Long time no see. I didn't recognize your name there. All right.
No, Prasad.
Prasad, yeah, I assume. All right. Okay, cool. So this is the angle we want here. Any thoughts on how to find it? So we can't use Pythagoras.
I have to thought
You have a thought? All right. What's your thought?
So, don't laugh at me.
I wouldn't laugh at you. It's all right.
Okay, so I minus 44 from 180.
The minus 44 from 180.
The angle missing there.
All right. Let me do a different color. So we just adding on, right?
Yeah.
So you're saying that this angle here was 180 degrees minus 44 degrees,
Yeah.
right? And that's because they are supplementary angles, right? Because all north lines are parallel, those two internal angles add up to 180.
And you minus it from 360.
Right, and then correct. You can now minus that from 360, and you'll get this whole piece.
But I remember you doing you said it easy to split it.
Right, you could do that too. Right, so check it. Now, if you do that and you find this angle here, you get 136. And then if you subtract that from 360, right, you get the whole angle.
But not that specific angle.
Right, but the thing is, we have this piece here of 105, and you can just minus that from 105, right? So check it. Let me just write it. Right. So let's go that again, right? To find this angle here, we could do 180 minus the 44 degrees, right? And that's because those two angles are supplementary because of the north lines being parallel, right? And now what you're saying is after that, we could take that from 360 degrees and we'll find the whole angle on the next side. But the thing is, we don't want the whole angle.
I added the 105 one time from the 136.
Well, you can't add the 105, you gotta subtract it. Because remember, you just want this piece here, not so?
Yeah.
Right. When you subtract that 136 from the 360, what you find is this whole angle here.
Oh, that.
Right? So to find the piece on the inside alone, what would you have to do? Right? This whole angle here. You'd have to subtract this angle.
But So what if I did it like 136 plus the 105?
136 plus the 105 minus from 360?
Yeah, that's it.
That's fine, because think about it. You could do right. So 180 minus the 44 degrees, right?
119.
Plus the 105, which will give us this whole angle here. And then you can subtract that from 360. Okay, I understand what you were saying, and that is perfectly valid.
I have a question.
Sure, what's your
And
question?
that B alone, that would be 180 minus 44 alone.
Correct.
If they were asking for that.
If they were asking for that, yes, that's correct.
How did you ask for that? Like find the inside angle.
They could say find the angle ABN, right? From A to B to N.
So the angle inside is 119. I got 119.
119, alright, check it out. So you have 360, 180 minus 44 is 136. 136 and 105 will give us, was that 241?
Yeah.
So 360 minus 241 is equal to 119.
Oh, this is good.
Alright.
What you do there?
I 180 minus 44, 136. 360 minus 136 will be
And then,
24 minus 105, so like 119.
yeah, that's fine.
So 360 minus 134.
Right, now that's one option to do it. Anybody want to see our next option?
Yeah.
Alright, so check this.
Wait, so the angle
Yeah.
is 119.
The angle is 119, that's correct. So let me go in.
I remember the one that you had because I had problems with how many like.
Alright, so check this. An alternative to doing that is to actually extend your north line going down. Now what we've done is we've broken the angle inside there into, let's call it a left side and a right side. Okay? Now the thing is, if you focus specifically on the right side, what angle is that represented by that arc there? 180 degrees. And from that 180 degrees, we have 105. Not so?
Yeah.
Alright. So all we have to do to find this piece is do what? 180 minus the 105, which will give us 75 degrees. On that left side, anybody see any connection?
Yeah, and then to find the B, you just do the working and you get 136.
No, hold on. What about that Z?
Oh, wait.
That's 44.
Yep, that's 44 degrees there. Right? Now that's part of the beauty with math. There are usually, in many instances, more than one way to find an answer. And the correct answer, the groupings are all equally valid. No, it is. If I have a highlighter, yes, I have a kind of pinkish one there. Alright? Alright, but it looked like everything on the live flowing relatively okay.
Okay, we'll be same way for the next side.
Work the same way for the next
It's
side.
an A, B, C, so all the information that's on the C side.
Well, remember, that worked there because of how the lines form the angle. C now, I don't know if it worked the same way. Right? And this, by the way, 44 and 75 will give us same 190. Alright, so the answer for angle ABC is equal to 190. Okay, anybody have any question on the item? No? Alright. Alright.
So, since we had the angle inside, we can find the length between A and C.
Right, so that is actually what the next piece of the question is asking. I'll scroll back up just now if anybody in live is taking some stuff down. I'm going back up. I just want to scroll down. Right, so the next piece of the question is calculate the nearest kilometer, the distance AC.
So
let's take a look at the question. Whoops, what am I doing? So that distance AC is represented. Let me just put a little more color here, right? By this blue line, that's AC. Put green just now, don't worry about it. Alright, so we have in our setup a triangle. We have a 52, we have a 72, and we have a 119 angle between them. So what can we use in order to facilitate finding that distance AC? Cosine rule is correct. Alright, so we could use cosine rule. Nafisa. I hope I pronounced your name correct. That's correct. Use cosine rule. Alright, very good, Nafisa. Alright, so cosine rule will tell us from here. So we're looking for b. So b squared is the subject of the formula. So that's equal to a squared plus c squared minus 2ac by cosine b. Alright, so a squared, so that's 72 squared plus 50. I'm kind of going small. No, we're looking for b. So we're using a and c. In the other one, we had a and b, and we were looking for c. So depending on, I mean, you could use the formula. Once you label it a, b, and c correctly, you could use a, b, and c all the time. Alright? So this is minus 2 by 72 by 52 by cosine 119. Alright, so somebody could plug that up in a calculator for me, please. I don't have my calculator with me today.
About 11,580.25.
11,518.25?
Yeah, 2%.
Anybody else can confirm that? Yeah? Alright, very good. Alright, so b now, so that's b squared, right?
Yeah.
So that's b squared. So to find b, what we have to do? Find the square root of 11,518.25, which is approximately, yeah?
Let's walk the three rules between
You work it? 72 squared, right? Plus 52 squared. What's that?
That's sine rule.
Sine rule have no minus or subtract. Sine rule is purely division. Look the formula here. A squared plus c squared minus 2ac cosine b.
So that whole line you plug it into the calculator.
Yeah, you're plugging that whole line into the calculator. That's correct.
So I want 107.3.
107.3?
Yeah.
What year?
107.3. Now they set to the nearest kilometer. So the answer there would be,
407.
right? So therefore AC is equal to 107 kilometers. And you can write to the nearest kilometer. Yeah, it's taken again. Yes, Faith, thanks very much. I'm sorry about that. Why is it sticking?
518.25.
Yeah. Live sticking. Yeah. Alright, 1 sec. Why? I don't understand. What's the story? This notationist.
You don't have to have 7 point.
107, yeah, but it's set in the nearest kilometer.
So 107.
Yeah.
Alright, so okay, you'll get some more work. And now see some more. Alright. If you live disconnect, guys, I'll just reconnect it, so don't worry about it too much.
It's on the same thing for class. So they're fine. Do the same thing and then they add on whatever it is.
How do I refresh? Alright, cool. Let's put that back. Let's go here. Alright, so I think, right, so you guys are now up to what I have written on the board. Alright, there's one more part of the question, right? It says, show that the bearing of AC to the nearest degree is 2/6. Let me scroll down. Oh, the line not sticking. Oh, the page sticking. It don't want to scroll. Oh, okay. Alright, thanks for scrolling all of a sudden. All of a sudden. Alright, cool. Wait, where the question went? Right, look at here. So, show that the bearing of A from C to the nearest degree is 260 degrees. Alright, so the bearing of what from what? The bearing of A from C. Alright. Okay, so the bearing of A from C. So what we're gonna do, alright, let me recreate a diagram down there. So that way I don't have to erase stuff. Bearing of A from C. Just see who came, please. Might be Laurel and Amy. Hey Amy, how you doing? Hey, afternoon. Yeah, I got it, but I was on the live, so I didn't respond. Sorry about that. Yeah, I got it. Alright. What was the answer we got just now for AC?
107.
107. Alright, cool. Yeah, we're doing a couple of variance questions. I just put aside a multiple choice for you to carry home and do. Right? We're going to switch to circle geometry just now. We're still working the 2017 question. Alright. Okay. Alright, so that's C there. Alright, so the bearing of A from C. Actually, no, I don't like how I'm looking. Alright, so 72. This is C. So the bearing of A from C. What's that? Right, now what is a bearing again? The angle between the north line and the starting point and the line joining the 2 points. Go in what direction? Clockwise. So what we're going to do, let me get a blue pen going here so we could tell the difference in the original diagram. So we're going to add on some stuff here, right? So we have a north line here. And we're looking for this angle here. Right. Now, do we have any other angles in that triangle? Well, what apart from the 119?
For this angle, can we just 180 minus the 190 and divide between it 12?
180 divide by 2. That's if it was an isosceles. Is it an isosceles?
No. Can't you just do that point there by D? Can't you put 90 minus 44?
That's 90 degrees? How you know it's 90 degrees? Alright, I think we back up and run in there. Yeah.
Okay, you know you don't be corresponding to the angle outside this point, you know?
Yeah, we could do that. Yeah, so you mean draw a line going this way instead?
Yeah.
Alright, and then you'd have this angle is 105 here.
Yeah.
And then we'd have to find out there are usually multiple ways to find the same answer. Alright. Alright guys, we're back on. Hoping you guys could see. Actually, it's still looking like it's sticking. I'm not seeing any kind of. Anybody on the live here could tell me what's going on if anything's sticking still?
It says offline.
It says offline?
Yeah.
Alright.